Good morning, everyone. I'm not entirely ready on the stream setup front, but we'll get started. I got a different, I'm using a different tripod here for the phone. I guess it's still pretty touchy with stuff, but basically it's a tripod that came with my blue snowball microphone. And yes, I know I have like this shadow over my head. I need to figure out the lighting better for when I'm seated at my desk. Probably need to get just another box light for over here and then a face light of some sort. But I got the little mini tripod stand thing that came with my microphone. I got an adapter for it so I can put a quarter 20 mount on it, and then a ball head, and then the phone tripod mount thing. So we've got a new angle here, and as you can see, I am typing today on my new Cornelius, which I'm very excited about, and this thing is heavenly to type on. Nice, Adam. Good job. I'm really happy when people build stuff on their own and enjoy it and stuff like that, so that's awesome. I'm gonna turn my music down a little bit. Okay, there we go. So yeah, today we're gonna be working more on the trackpad stuff. Let's see if I can find all my windows. Okay. Get them on the thing. Okay, well that one's already up. Come on, iTerm. Go. So we don't really need iTerm today, I don't think. It's mostly going to be in CircuitPython. Or MuEdit, I guess, is the official name. There we go. Okie doke. And then Safari. I don't remember what we had in Safari. But we'll use it. Okay. Shrink this a little bit so it fits. There we go. Hooray. So yeah, today what we're looking for is to try to implement just basic reading of the trackpad data from the trackpad in CircuitPython. And then I'd like to figure out if I can get the interrupt pin stuff working in CircuitPython, because I've never done any like asynchronous type stuff in Python, or really much of any language except for like Go, but that's usually the asynchronous part of it is handled by a higher level thing, and you just like write a handler, which may be all you really need here too, but we'll see. And then if there's time and I feel like doing it, maybe I'll try to start working in actual in Zephyr to try to get just basic, you know, like we did last time, firmware ID, firmware revision, and read that from the controller, because I think that'd be very handy. Hello, Mr. T, and also that's awesome. I'm glad my stream helped someone. That's very cool. Good job, Adam. And I just realized I didn't fill my water glass. So I drink a lot of water. I really like ice water, but I don't have like a really great source of water down here. I mean, I have a sink and I have a washing machine. There's water down here, but it feels weird drinking water out of my faucet that goes in my shop sink. I don't know why. I just don't. I don't know. So I've thought about like, oh, should I get a water cooler? Should I this? Should I that? And then I'm like, wait a minute. I can just get a giant. This is a 2-liter water bottle, and I put ice water in it. This should last me most of the day, if not like all day. This out. I wish I had a better pour mechanism, because this just like, it's got a straw adapter, but I don't know how well that pours. And otherwise it just has a big round top. So this could get messy. Fortunately, it's just water. So if it does get messy, it's not really all that messy in the grand scheme of things. Nice, yeah, I've got some big water containers, but I feel like I just go through them really fast. But it's, you know, a 64 ounce, or 2 liters for those of you who use proper units. That's just, I think it's gonna be kind of a game changer as well. So, I'm trying to think, is this display, well, you can't see me moving around, is this display useful? Should I move it to the side and then put my terminal here? Although my terminal isn't going to be used probably very much today. I don't know. This is mostly a typing cam at this point, because I haven't really started using this, and there isn't much to use anyways, because it's just like, oh, okay, I'm gonna touch the trackpad now and read the data. We'll see. Alright, let's get cracking here. So first off, let's just make sure this still works. Okay, so yes. We've got value of 0x00 is 7, value of 0x01 is 3a. This has our new dried out functions that we use to read the register and registers and clear the flags. So, the next thing we want to do is ignore the hardware data ready, because what I'm going to do is I'm just going to fake it. I'm going to poll, and every time I poll, I'm going to clear the read ready bit. So the idea is it's going to be, you know, we're going to wrap, it's going to be like a while true wrap read register SPI, and then thing, whatever thing is, and then wrap write register, wrap write register SPI thing, and I think I just write a 0 to it, so 0x00, like that. And then we'll print out the read. Red foo from bus, whatever. This is obviously just like pseudocode-ish for the moment. Format, foo, something like that, right? We'll move this down. You know what I want to do actually is I want to change. Can I do like save as? No, that would be too handy. Hello, Brick Motion. I'm doing well. How are you doing? So you don't see my iTerm, but I'm basically what I'm gonna do is I'm gonna copy this code.py file. I'm gonna copy the code.py. I was just thinking, should I make a Git repo on the Circuit Python on the controller? And no, I should not. But I'm gonna copy the code.py file as it is right now, just to have kind of a backup of it. I don't know. If only there was some revision control system that I could use, but not today. Let's see. So I need to /volumes/CircuitPy, and then I want to copy code.py to read the firmware.py. Okay. Now I can delete all the rest of this stuff. Not all of the rest of it, actually, because we do need to do this startup sequence thing. Oops, okay. Okay, so here is going to be one thing we need to do, because the 0x03 and 0x05 registers, if I recall, are the configuration. Yeah, there's sysconfig and feed config, and we need to change the feed config because right now I have the feed disabled, which is not all that useful. Oh, okay, sweet. Hello, Cyan Duck. Alright, okay, data output. To receive position data, the data feed must be enabled by inserting the feed enable bit or flag bit 0 register 0x04 feed config 1. Once enabled, reporting begins. Pinnacle can report position as relative data or absolute data. Relative is identical to a mouse or pointer. Absolute data is a grid. Okay, so I want relative, so I'm going to write this stuff down a little bit. I want relative. I want 0x04 table 5. Excuse me. Advanced features for relative mode can be set using flags in register 0x05. So 0x05 is advanced relative. Okay. Oh, here's table 5. That's convenient. Okay, so bit 5 is ignored. So I want the feed enabled. So, okay, so we're gonna just real quick, for register 0x04, we're gonna make a little diagram here. I'm gonna put 1, 2, 3, 4, 5, 6, 7. Okay, so that's 0 and 7. And we want feed enable to be 1. We want data mode to be relative. Not sure on the filter thing. Definitely is a not X or Y disable, so 1, 2, 3, 4, 5, 6. So I don't know for 2, so I'm going to leave it as 0, but I'm not going to write it down because I don't know yet if that's 100%. But I definitely want Y and X. That is ignored. And then these two are ignored as well. So bit 6 and bit 7 are ignored, and it says here X and Y data invert is only available in absolute mode. Disabling the Y-axis will not allow regular tracking, is not recommended for typical applications. Okay, so it's just there as a completeness thing. So we want so we want to set the value of 0x04 to 0x01. It looks like. All right, that's easy enough. Okay, so I am going to put this right here. Oh wait, configuring 0x04. 0x01. Great. So that enables the feed. It's got all the right values for everything else. So for I'm gonna just throw a little mini comment thing in here saying this is feed config 1, and then right register SPI 0x05, and then 5 we want swap X and Y. Don't know yet. I think in a perfect world, like in ZMK land or something like that, I would have a reasonable default based on where the hardware is, but then or based on how the hardware is intended to be set up, but have it be an option so that you can change it if you need to. Like maybe in a later revision they make it so this, you know, this is X and this is Y, but a later revision they make it so that's X and that's Y or something. Not that I think they would ever do that, but just to make it so people can just expose that functionality. But for now, I'm gonna leave it as just ignored for now, actually, because I don't know what I need yet, and I also don't really care because at this point I don't really care what the data is, just that I can read it. Glide extend disable. Glide extend is Cirque's patented motion extender technology, allows the user to continue drag function when edge is reached by lifting and repositioning the finger. You know, I think I'm gonna go with 0 on that. Because I feel like with a mouse pointer, if you do that anyways, that's gonna just naturally do that. I don't really know what that does, but we'll see. Scroll disable. Oh, I didn't realize you could scroll on these. That's cool. So I want to look into scroll disable just to see what that, you know, how that scrolling feature works and stuff like that. if it's what I think it is, like you two-finger scroll, because that'd be really cool to expose that. Because, you know, obviously it's kind of hard to do on these little teeny ones. But the bigger ones, like that is something they could totally scroll on. Right? Maybe even scroll side to side. I don't know. I'll have to look to see how that gets exposed. Something to look into. Alright, secondary tap disable. Allow tap in the upper right to simulate an activation of the secondary button. I don't want mouse actual taps right now. I would expose those as keys somehow. Maybe later it'd be cool to have. I'm trying to think, because the big thing I want this for is for my iPad so that I can select and highlight text. That's like 90% of what I want this for. The scrolling thing would be nice, but I can page up, page down, or scroll on the actual display with my finger. So like being able to tap, I actually don't really like tap to enable. I like a physical mouse button or a physical, you know, I tap or I use my middle finger or one of my other fingers to move the pointer around, and I click with my thumb. And these are not big enough for that. So I don't like the like quick tap thing. I don't know. Anyways, we'll figure it out. So right now, yeah, but so I guess what I'm trying to say is like, with that, could you like tap and then would it still register as a hold? Because if it doesn't, then I don't care about this feature. Maybe I expose it as a driver thing and someone can enable it in future firmware. I don't really care about it, so it's fine. We'll see though. And then IntelliMouse enable. So IntelliMouse Pinnacle's relative data packet to 4 bytes. The 4th byte will report scroll data. Don't care about that for the moment. Actually, we'll leave that as optional. Okay, so go over here. 0x00. Great. So that should be configured. And now what that means is I should be able to start reading. So there's a clue here that says change Pinnacle's relative data packet to 4 bytes rather than 3. So what I think I'm going to need to do is x equals that, and then copy, paste, then y,
he was immediately suspended and removed from duty. His
then z.
is absolutely unacceptable.
Relative data mode data packet.
Apologizes to our customers for this incident.
Relative data mode supports 3 button inputs. Button data can be generated by the actual button tops.
There's 2 people involved in this.
Okay.
What can you say about your role? Did you?
So we're gonna stick this up on the monitor for now.
That's why I want to talk to my lawyer.
Data packet. What we care about is button data is also reported in packet byte 0. IntelliMouse is enabled. Scroll data is an additional byte, packet byte 3. Oh, okay. So this is actually fairly complex in terms of it's not as simple as XYZ. That's good to know. PB1, PB0, PB1, PB2. And then what I want to do here is something like X, Y, Z equals parse packets PB0, whoops, 0, PB1, PB2, something like that. And then we'll do a def parse packets PB1. I just changed my combos for enter and stuff like that. Because previously the combos I had, at least on the Zephyr, and still are because I haven't ported all these changes back to ZMK. Previously the combos were vertical combos, so this was enter, this was parenthesis, square bracket, and curly bracket. But vertical combos, I didn't really like them, single finger vertical combos. So I went with 2-finger combos, left to side, or side to side. So these two are for parenthesis, these two are for square bracket, these two are for curly brace, and then these 3 are for enter. But I have to remember that I'm not just hitting... So like, occasionally you'll see me type HTN or something like that, and that's because I was trying to hit enter, but I hit it on the home row instead of on the top row. I maybe should just change that to the home row, but for now it's fine. But I can't just use 2 fingers on the home row because those are all very common rolls. Yeah, I've tried. It's terrible. Like, I had TN as my enter key for a while. And I say a while, I mean like all of 10 minutes because it was so awful to type with because I was constantly hitting enter by accident. But I might move that because these 3, you know, the only time you would roll that is nth, and I'm fine with that as like an, you know, as an accidental roll. But I figure a 3-button combo is also harder to roll, or to accidentally roll, I should say. So we'll see. Something to play around with. But it's funny. The Cornelius has 48 keys on it, and I'm using 34 of them because I've taken my 34 key layout and ported it directly. So like, these keys here are not used at all. They do nothing. This one is supposed to lock the computer, but it's not for some reason. I don't know why. I just haven't bothered to figure it out. And I haven't set this one up to open iTerm, but I want to. But yeah, otherwise, the outer column, these just don't do anything. Because this is kind of like my standard keyboard now, right? My Zephyr. And so I ported that to this, so I didn't have weird, like, oh, well, I've got an enter key here, but that shifts these thumbs over because that gets messed up when I go back to the Zephyr and stuff. So just gonna, yeah. Plus, combos are pretty sweet. Like, I don't know. Anyways, it's rambling. Okay, so P2, and then we will pass for now. I can't remember if you can actually do that directly like that with Python, but we'll find out. You know what? Actually, I'm gonna write the parser for this right now, because I know I need to read 3 bytes. Every time I get an interrupt, I need to read 3 bytes and then write the clear bit. So I just need to read the 3 bytes, parse it, and then there we go. Okay. I'm caffeinated at this point, like freshly caffeinated, so my mind is going a million directions at once. Which is why I keep kind of bouncing around, but we will get there. Okay. Oh, I guess so. It is kind of uh, let's see. It's not XYZ, but it's like metadata XY. So.
You are a function of this total galaxy. The real deep down you is the whole universe.
And then I'm assuming something I really like about typed languages is that I know exactly what this is returning with a typed language. I have no idea what this is. I think it's a byte. No, it's a byte. No, it's a single byte. Byte array 3. Okay, Python byte type. Built-in types. Byte. Okay, so that is a byte. Oh no, it's a byte array. String and bytes literals. The bytes built in. What I'm trying to figure out is how, like, can I... We'll just do it. We'll test it live. So, PB0 bracket 5. So we'll do y sign equals and then x sign equals PB0 4. Okay. Bit 7. Actually, I'm gonna do it this way. Equals PB0 7. And then it's PB0 6. That way I know I've accounted for all the bytes, or the bits. So bit 3 is just 1. So equals PB0 3. Remember, if you can do this in Python, but we're gonna try it. Okay. So then, from bytes. Then X must be a string, bytes, or byte array instance representing a literal integer literal in that. Okay, so then X, whoops, X equals int, and we'll do PB0 or PB1, Y equals int PB2. And then we'll multiply that by y sign equals 0 1 -1 change this to X sign instead of Y. Oops, there we go. And then don't actually get a Z because we don't need to. Turn X, Y, that. I don't know Python well, so there's a really good chance that this just doesn't work at all. That's fine, because it'll let me know. Okay. Line 71. Invalid syntax. I suspect Python does not have a ternary operator. '79. Syntax. Okay, so thing. Okay, so I need to figure out what thing is here and that. So should actually change this to fix me. Relative data mode packet. So data packets are reported in different registers for Pinnacle and Pinnacle AG. Great. I don't know which one I have. Does it say? We'll find out. Hopefully it's easy enough to figure out. Okay, so packet byte 0 is 0x12. Packet byte 1 is 13. And packet byte 2, 0x14. I'm on macOS. As you can tell by the Apple keyboard, which really I use that Touch ID sensor all the time now. It's like unlock your computer with Touch ID or type password, and I'm like, well, I can type a password here. I can just reach up and touch that. So this is a $150 lock for my computer, basically, because I looked at the iFixit teardown of the of this, and the keyboard itself is paired to the Touch ID sensor in the factory cryptographically. There's almost zero chance I can reproduce that outside of the factory. So there's very, 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 very little chance that I will be able to rip the Touch ID sensor out of there and put it in a keyboard and have it work. So I kind of don't want to destroy a $150 keyboard to do that. But it also means I have a $150 keyboard that I don't have any use for. I mean, I have plenty of those already, but at least they're like fun, right? I mean, hello? Like, this isn't $150, but it's probably not far off if you count all the parts. And there's another one sitting underneath it. There's 3 macro pads sitting right here, and I've got a box full of keyboards behind me, and yeah. So, that's always fun. Contains calibration configuration bits, number of samples generated per second, number of Z. Okay, and then the clear I'm sure. I'm not super... I wanted the Touch ID sensor. I don't know if those third-party fingerprint sensors work with Touch ID to support the things that Touch ID can do. I would doubt it. There's probably... Like, if you have a third-party fingerprint sensor, it probably requires its own software, and it can do things like unlock your computer or work as a smart card, like your if you have a common access card or something like that, you have the smart card, and then the Touch ID or that fingerprint sensor can act as your PIN for your smart card or something, or maybe it's got a built-in smart card and the fingerprint reader is the PIN effectively. But it won't work as a Touch ID thing, which if you want to use it for like Apple Pay or any of the stuff that uses Touch ID on a Mac, you need proper Touch ID. And also, like, I don't need it in my long-term plans, because my long-term plans have me using an iPad as my primary desktop, and I have been for a while. With streaming and doing this sort of stuff, electronics, iPad just doesn't work. I can't. I've tried so many different ways, and it just doesn't work. I have to have a functional, I have to have a proper, like, I don't want to say desktop computer in the sense of, like, a computer that's not a laptop. Although also that, because or you need at least a desktop grade laptop. You know, my MacBook Air just doesn't cut it. I've tried. I have an M1 Mac Mini that I'm using, but the iPad has Face ID, so I don't need the Touch ID sensor in the keyboard because I have Face ID. It's even better because it just pops up and it's like, hey, Face ID authentication, and boom, it scans my face and off to the races. So it was more of a like, can I do it? And I'm willing to spend the money, make the sacrifice, and you know, do the science required. But you know, the iFixit teardown basically told me it was not possible. So I don't know. It would be really cool if Apple had a way to had like a embeddable Touch ID sensor, but that is absolutely not their thing. They've never, as far as I know, beyond the like Apple, the original Apple days, had stuff that's like, oh yeah, here's like one of our major pieces of technology on a chip that you can embed into something else. No, they don't do that. It's like, you want Touch ID, you buy the keyboard with Touch ID on it. So yeah, I think there might be, it might work natively in Mac OS to authenticate to your computer with one of those third-party fingerprint sensors, but I suspect it's gonna require at least the additional third-party software. It'll integrate properly because, you know, those sorts of card-based or fingerprint-based authentications stuff is required for US government stuff in a lot of places. You know, you have to put your common access card into your computer to turn it on or whatever. So like, it makes sense that the Apple would have, if not first-party support for those, first-party integration points for those. So yeah, that's probably it. You have to pay, well, you'd probably have to do a lot more than $100 or €100, £100, whatever certification, because they would probably have strict MOQs. You'd need 10,000 of them, and then it's like, okay, well, to put it in a Cornelius, okay, I can do that, but to put it in, sorry, let me do apples to apples. To put it in a Reviung 41, it's one thing. To put it in a to put it in this artsy board is another thing, even though they're both using Pro microcontrollers and they're functionally equivalent in every other way besides their layout. Like, these do literally the same thing. This has an OLED display on it. Oh, I can disable that if you need to. So like, the MFI certification is a little annoying because it's not a class certification, it's a device certification. So the device would be, the device in question would be like, which model of keyboard. And since we're like, QMK? Like, is that a model of keyboard? So I just doubt Apple will ever have that. But I think what'll happen is, and I'm actually really surprised that the iMac and stuff like that doesn't have Face ID. Like, when they came out with the new iMacs and it didn't have Face ID, I was like, what? That doesn't even make sense. Why wouldn't it have Face ID? It's got a camera built in. There's plenty of room for all the sensors. Why make a keyboard that has all this when you can just embed it in the thing? And I don't get it. I really don't. Okay, so clear flags. So instead of doing this right manually here, I just do clear flags. Yeah, it doesn't have Face ID. Because it has Touch ID in the keyboard. But why? Then you don't need to upgrade the keyboard. I don't know. I mean, maybe they did it because they were like, okay, well, how do we do Face ID with the Mac Mini then? Because you can't. The Mac Mini is a little box that sits on your desk, or under your desk, or on the back of your monitor, or whatever. And there's no way they're going to be like, oh, well, here's the third-party display that, you know, has Face ID built in. Or like a dedicated camera webcam thing that has Face ID. But I feel like that's such a niche, such a tiny little thing. Because like Face ID on a MacBook, Face ID on an iMac, all those things make sense. The Mac Mini is such a small portion of their user base, I gotta think, that who cares if it doesn't have Touch ID or Face ID? Like, don't design an entire... I don't know. Maybe there's something weird with Face ID patents, or... who knows? Let's see. Int object is not subscriptable. Okay, so a bytes is just an int. So that's what this is saying here. So we want Python read bit from int. Extracting bits from a byte. Yeah. Oh, wow. Okay. So the way I read this is actually to AND it with a 0B 1 0 0 like that. And then shift it. So actually what we want to do here is make it 1 if it's 0, else -1, because then we don't care about the value anymore. So we don't have to shift it. There's probably an easier way to do this, but this will work for now. .67 invalid syntax. That's not enough. Oh, yeah, it is. Line 81. Clear flags. Oh. SPI. Getting close. Okay, well that's doing really fast. But look, there's data. I'm reading data from the thing. Holy crap. Now, yay. Now what we do, how do I get out of this? Oh, great. I done killed it. Let's just see here. Let's just bypass that entirely. Save. There. Okay. Great. So we are successfully reading our XY data from the thing. Can I just cancel that? Okay. Now what we need to do is wire up the interrupt pin. So circuit Python interrupt handler. This was a lot easier than I was expecting, to be honest. External interrupts, def callback. So what I want to do here is, instead of while false, so interrupt, wait, we already have that set up here, isn't it? Yeah, so we have RR. So RR.RQ. And then we trigger pulls. You know, I don't think this is right. Okay, digital in out. Is that a pin? Module name sheet. What version of CircuitPython is this? 6.3.0, and this is docs for 1.0.0. Okay. That's a little more like it. Okay. How do I search this though? There. Interrupt. IRQ. There we go. No, it's using LoRa. Damn. It's not what I'm looking for. Blue Fruit SPI. That's... Oh, damn it. Okay. Optional IRQ pin. So this is all like abstractions, which maybe I should be using an abstraction, but circuit, Python, SPI, interrupt. Now I'm just going to do IRQ. Why is that? Well, I could just loop on the IRQ pin value. Which I'm actually going to do real quick, just to see. So while false, so while rr dot value, wait, okay. And that's not doing anything. Of course, that'll just exit immediately, so it doesn't matter. That doesn't work. How do I indent this more without manually doing it? Okay, well that at least kind of does what I want, although it's just sitting there spinning on the pin. So it's basically running at 100% CPU or whatever the equivalent is, doing nothing. But at least it kind of emulates what we want, and it's not just sitting there spamming out data. Damn it. Why? Okay, Google, why are you giving me version 1.0.0 docs? Like, that's just not even fair. And for whatever reason, I can't change the version? That's hilarious. Okay, circuit, Python, interrupt handler. Okay, there we go. Does not support user-written interrupt handlers in the way that MicroPython or Arduino do. However, the course does use interrupts internally for specific functionality, such as pulse in, count IO, rotary IO, etc. MicroPython supports pin interrupt handlers, timer-based interrupt handlers. Okay, so TLDR, this is as good as it's going to get, I think. This is not quite polling, because polling would or I'm polling on the pin, not on the full data set, right? Not the registers. So it's I guess it is polling, but it's a different kind of polling, I guess. But yeah, so this is just sitting here spamming, and I would, if I was to do this for real polling this way, what I would do is I would set up some sort of like fallback or fall off interval, such that like when there's activity, it reads really quickly, it pulls the pin really quickly to the next one to make sure it gets as fast as possible. And then if it gets, you know, say 10 milliseconds down the road or 100 milliseconds down the road and there's no more data, it backs off a little bit and then does a little bit of back off to some sort of max interval, so that I'm not constantly just spamming the CPU and letting it sleep, but I still get the higher, you know, response rate when there is data to be read, so that 90% of the time you're sitting here and it's doing nothing, but it's like the second you touch it, you know, within say 50 milliseconds would be the max polling interval or something like that. It'll catch that you've got data, and then it reads it real time until then. Yeah, but this is cool. This is proof of concept right here. Like, this is doing what I want it to do. This is very exciting. Although for some reason I'm getting negative 251. In the negative direction, I'm getting a lot of very large numbers. You know what I bet it is this int is expecting this PB1 to be a signed integer. Oops. Function does not take keyword arguments. No. Byte order determines the byte order. Um, $83, 71. Function does not take keyword arguments. Okay, whatever. You know, I don't actually care that much about this, because this is not my final implementation. This is just a proof of concept that it works. But it does seem like whenever it's negative, it's very large value. But positive, it's very small values. Or relatively small values. But like, even this tiniest little bit of negative x is minus 255. That doesn't seem right. Tiniest little bit of negative y is minus 255. Anyways. Oh, and... Okay, no, that's right. Okay, anyways. That's the MicroPython side, or the CircuitPython side. I think it's time to try this out for real. We've got the functions that we need. We need the read register, write register, and clear flags. Or we don't need to clear flags, but it's just a handy thing. We know what things we need to configure, and we know how to parse the packets, and we know how to, well, you know, ostensibly how to parse the packets. This part could use a little work, but that's fine, because that'll be completely different in C anyways, because we're not dealing with rando whatever the fuck it's giving me types. It's actually typed, so I can reason about it more easily. There we go. Okay. So one thing I want to do... So one thing I want to change just slightly is I want to cs.value equals false. This is being a good neighbor on the SPI bus. So... and then SPI dot unlock. Try unlock. Basically what I would want to do here is whatever the equivalent of SPI dot lock or unlock would be, and then here I would want to SPI.trylock. While not SPI.trylock. Pass. And then I would cs.value equals false. That selects the device, and then cs.value equals true, and spi.unlock. Something like that. Great. Of course, like I said, that doesn't actually work. So, or maybe it does, but I didn't do the unlock bit. Oh, and this, of course, is never going to work because it's still locked. It's there. Oh, excuse me. Sorry, headphones users. Great. You know what I didn't bring down? A banana. I'm not frustration bananaing. I'm just, it's a good time to have a banana. So I will be right back with a banana. And then we're going to figure out how to do this in Zephyr. And I'm going to be very happy about that. Okay, I am convinced. Opening a banana from the bottom is easier than from the top. Because from the top, if you try to do this, you smush the banana, whatever, otherwise you gotta cut into it with your fingernail. But someone mentioned you just squeeze the bottom here and it pops open. Just a little bit at the very tip. And it works. Like, let me do it down here, maybe. And then you can peel it. So, okay, I'm convinced. It's easier to eat from the other. And then you've got a convenient handle. So when you get down to the bottom of the banana, or the end of the banana, I should say, because this is the top, maybe. You still have something to hold on to. It's kind of like chopping an onion. If you're chopping an onion, you don't cut the root off, because you need the root. That's your handle. And then you make cuts into the onion, but not all the way to the root. And then you slice across it, and then you throw out the top. You're just wasting a little bit of onion. It's not that big of a deal. Or cut it up separately, whatever. But you have a handle. Okay. So let me do a little bit of rearranging here. We're gonna take the CircuitPython window away. We're gonna move this over to here. We need to shrink this window quite a bit. Oh, because wait, that's not the... Yeah, it is. Why is this not updating? Okay, but why is this? Whoops, that is not what I wanted. Okay. And yes, I just threw the banana peel outside because I don't want to put it in the trash down here because I never change the trash down here. And banana peels get really stinky and they collect fruit flies and stuff like that. I just don't want that shit in the basement. I say I never take out the trash. Obviously, I never take out the trash. The recycling. But the trash can doesn't get changed out very much either, just because I don't have a lot of volume of trash down here. Mostly recycling. But I just don't want food scraps in the trash down here. Okay, so got this over here. So what do we even have in this project? Just a Docker Compose and that. Okay, so what I've got here is this is the Zephyr source code, I think. Is there more? I haven't used more in ages. Yeah, this is the Zephyr source code. I thought I had sticky notes for the pins on the controller, but that's fine. Just leave that up. On string format, SPI devices, cd shell. So we're gonna go to the main Zephyr docs, and I want to do the getting started guide. And since this container is an Ubuntu container, I'm just gonna follow the Ubuntu instructions, except for stuff like udev rules, because this doesn't have udev, it's a Docker container. If I want to bring a device in, I need to pass the device flag, but I'm not gonna bother, because I'll just manually copy the firmware over, for now anyways, until I get really sick of doing that. Get Zephyr and install Python dependencies. Okay, then how do I hack on Zephyr proper? Because this downloaded Zephyr from the internet. But I want to use my local copy of Zephyr. Development and contribution process. Nope. Development environment and tools. Building configuration systems, samples and demos. Application development. Okay, well, first thing I'm going to do, I guess. So this SSD 1306 is a driver in the main development branch of Zephyr. So I'm guessing in this directory here somewhere, there's a thing called SD 11306 something. there is. Okay. Supported boards, application development, build and configuration system, getting started guide. Okay. I mean, I guess, can I just mount Zephyr in there, but the... Does this just copy in the Zephyr source code and then Wes Update builds it? Or not builds, but thing. We're just gonna do it here for now. So let's do this find again. So drivers. That's probably ESPI. No? I don't know. Okay, so this is actually a bad example for me to look at, I think, because it's I squared C. Wait, there's samples. Let's peruse the samples. Oh, I didn't clone Zephyr yet? I didn't. I remember back in my day, it used to take an hour to download about 3 megabytes. And this was doing 16.8 every second. We've come a long way since 96. Well, I see SPI. ESPI. SPI Fujitsu or SPI Flash. So, okay, these seem to all want to use SPI for, or these seem to all want to be Flash things. So we'll just look at this one. SPI. Oops. / SPI. So these are applications, I believe, but it might not be a bad idea to write this as an application first and then try to write it into a driver. I guess. I don't know. We'll see. Let's go even more basic, just to make sure. Okay. It's basic.rst here. Okay. Simple application with function LED forever using the GPIO API. Source code shows how to configure GPIO pins as outputs, turn them on and off. Well, that's one of the things I need, is a GPIO output, because that's the device selector. So this helps me building block my way to getting a thing working. Wow, okay. T alias LED 0. Okay. So this code here is looking for, in the device tree definition for the board, LED 0. So if we look at these here, we've got LED zeros in all these boards. So there's the Cduino Shao. So let's actually just look at the Cduino Shao to see what pins and stuff we have here. So we've got LEDs. There's some aliases for compatible samples. Okay. Serial. Okay, so that is if I... So, okay, so that UART is here, and that's there. What is it? SAM0, whatever. And there's oh, no, wait, okay. So Circom 0. Circom 0 is what we want because that's the SPI. And there's depot. But I'm guessing there's an alias somewhere. So we've got aliases. I'm guessing there's something like that for, like, instead of Circom 0, it's SPI. Or maybe that's what it is. SAM0 SPI. Okay. There's an SPI driver. Okay, so this might be a lot easier. I mean, I guess it makes sense there's an SPI driver. I just didn't think about it. So let's see. Drivers, SPI, slash. I, there we go. Read the specified amount of data from the SPI driver. Read the specified amount of data from, or write the specified amount of data from the SPI driver. This is definitely the droids we're looking for. Can I really would like to get rid of this side without shrinking the window. Because that just shrinks it for me too. Okay, so I'm gonna go here, Zephyr. Samples. LED strip update RGB. Okay, so this is actually using SPI output, I think. And there's another driver, so there's WS2812 LED driver or LED strip. If I look here, there's SPI and GPIO, and I think the GPIO one is just bit banging. And that's what most keyboards probably use because they just use data out or whatever. Whereas SPI is an actual thing. Maybe they don't just use... let's see. Pro, micro, pins. Yeah, TX and RX. They just use the TX pin and bit bang it. Okay. Interesting. So much to try to take in with all this. Zephyr is very different from MicroPython as one might expect, because it's got device trees and it's got all this stuff and their drivers, and I'm just kind of like the sample here. So if we go back to samples, LED. Okay, actually, let me just look at this here to see. And no, because it's using pulse width modulation. What did I look for? Okay, so I found drivers LS or LED WS2812 at SPI. The fun thing about this driver here is it's just using the underlying LED driver. It's not using SPI directly. Not even the SPI driver directly. Like, it's using something else. So maybe that's just a bad example. Let me look to see what else they have. SPI flash. Is this LED LPD 8806? It's using the LED strip driver, which is fine, but I don't care about the LED strip. I care about the SPI stuff. I'm just looking for a good example to crib from. Okay, please connect the PS2 mouse to exercise. So this can act as a PS2 mouse natively. Like, it'll work. You can wire it up to a PS2 connector and plug it into a PS2 port, and it'll work just fine as a PS2 mouse. This driver in this sample here is, if you were to take that and plug it into this microcontroller, it'll then use that. I don't want to do that. I could do that, but I don't want to. And it looks like it says the sample can be built and executed on boards supporting PS2. So I'm guessing the board hardware itself for the controller has to support PS2, which maybe that's a really common thing. I have no idea. I would guess not so common. But this isn't what I'm looking for, sadly. I'm gonna just check real quick. Zephyr, SPI. Oh wait, didn't I just look at this? Yeah. Okay. I'm in way over my head here, and that's kind of frustrating me. It's going. Not super well. Because this is very, very different. I don't know what I'm doing. But getting there. Cornelius is very fancy, especially with the fidget spinner. Love the fidget spinner keycap. It's like probably the best keycap that I have, except for the bongo. I really like the bongo because bongo is cute. Right now I'm trying to like read this code and read the docs and read stuff and just kind of try to absorb, and I'm just not getting it. Drivers spi.h. Okay, public API for SPI drivers and applications. Polarity and phase modes, yep. I mean, this is all, I'm just looking at the... This is just the C version of this docs. Bus is the SPI bus. SPI config is the slave specific configuration. Helper macro extends to a static initializer for a struct SPI DT spec by reading the relevant bus frequency slave and CS data from the device tree. So I define this in a device tree. I bet that's what it is. And then I SPI DT spec get and device tree. So SPI DT spec get. Let's see how the LED strip does this. SPI DT spec plus. This PI is ready config bus. So that's construct device dev. Device.h. Sample device tree configurations for each compatible. Okay. We are getting much closer, I think. Oh wait, no, that's not what I wanted. That is one of the pieces I'm missing. Okay. So that circles all the way around. So I need to define this in device tree. And then I can get the device using that. I mean, I say that as if it's like, oh yeah, totally, that's easy. No idea. Brain hurts. Okay, I'm starting to see a few things here. So the DT alias, yeah, the DT alias for LED strip searches in this overlay file, and that gets built as part of the LS. This part here, whoops, that is not what I wanted. I can't click on that, can I? Weird. So there's Zephyr samples, drivers, LED, WS2812. Each of those sample directories is like an application, I think. Like if you were to go into the app directory of the ZMK source, same kind of thing. So I can take and skeleton out an app. Put in an overlay file for this. That gives me a device tree thing that I can mess around with. Okay, so let's do application development. Assume your application directory is home app and it's home app build. Okay. So what I want to do here is go to 3, so for fun times, slash read me dot whoops. Me. Then we're gonna go back down to LED strip. Actually, you know what? What I'm going to do even before I do that, just to validate my thinking, is... Oops. C dash A LED WS 2012 to development Zephyr Fun Times WS 2812. Okay, and then go to in container, and then we go slash workspace. And this should have the WS. Okay, so I should be able to then do this. And it's not going to work because there's no what am I trying to say? It's not going to work because there's no LED strip alias in the Arduino Xiao, but I should be able to add one. And also I don't have an LED strip to plug into this, which maybe I should get one, in fact. WS 28 strip. $30. Oh, that's 16 feet though. That is not what I want. Or that's an 8-channel one. $10. Yep, let's do it. I will actually purchase that later. Oh, this is downloading another copy of Zephyr even? Oh. Okay. gonna try or check something real quick. Docker. Let's see. Okay, Zephyr base environment variable looks like oh. Okay, so that's not where the Zephyr installation is. Or the Zephyr source code, that's something, I don't know. Arg. Oh, they use Slack. Okay, I'll deal with that later, maybe. I don't know. Yeah, I'm definitely losing steam here. Or at least losing steam to keep streaming, because I feel like this is not very compelling content at this point. Let's watch this clone, and for some reason it's going 700 kilobytes a second. Because it's inside a Docker container, it's just... It's just... Shouldn't even have to clone this, it's already cloned. I didn't realize quite how slow it was cloning. And that's what the problem was. I mean, that's going to take like 20 minutes. Okay, maybe not 20 minutes. It's going to take a long time, though. Yeah, I think I might just call the stream here for today. Play around with this a little more. Try to get this sample app building. Get a skeleton, like very, very basic. Like I can compile. It doesn't do anything, but it builds application up and running, and go from there. Because while that might be useful, like that's documentation that already exists, but so much of that right now is waiting for the shit to clone, and then I want to try to figure out how to have it use my locally cloned checkout of Zephyr instead of cloning its own, so that I can hack on Zephyr, rebuild the stuff, and have it do it. And that I can do off stream or something. I don't know. I'm getting frustrated. I could probably go for another banana. I don't think it's going to solve my frustration. I think it's just time to call the stream for the day, and I will continue flailing at this without boring all of you. So, that being said, Wednesday... Well, okay, let's just recap today. Today, CircuitPython got it so we can read this off of the device, and we have a faux interrupt polling set up so that we're not just spinning on reading off the device. We're at least just like spinning on checking that the pin is active. So we've proven all of that concept, that stuff works. And yeah, that was actually really cool to see that, to see moving my finger around on the device actually spitting out stuff into the console of CircuitPython. That was awesome. Like, that made me very excited. So I'm glad about that. Yeah, I don't know what else. I mean, really, that was the biggest thing that I accomplished today. But I think that was, I think that was still, that was worthy. Like, that was definitely a milestone that I've got this reading. And yeah, so now the next thing is really just to get a little more of a fully spec'd out or fully flesh out build environment going for Zephyr, so that I can try to port this stuff into Zephyr. I'm gonna do it as just a basic application first, right? And then figure out how to make it into a driver that I drop into Zephyr, or maybe that's the way it should be published, is as an application, and that application is a driver, and that if you want to use that driver, you pull in my repo. I don't know. I will talk to them. Another reason I want to do that off stream is because I don't want to sit and talk on Slack ever, but also not on stream, because I think that's boring. And also I have a bunch of... I haven't logged into Slack in a long time. I don't know what Slacks I'm in. There may be some... maybe I don't want y'all to see. Like, I know there's definitely one private one that I don't want y'all to see. It's not because it's bad or anything. It's just a group of friends from a long time ago. But they post some fairly raunchy stuff, and... Well, I guess you wouldn't see the Slack window, but either way, it doesn't matter. Talking on Slack on stream is boring to y'all. So, anyways, I am going to call the stream here. Thank you all for hanging out, for the support and encouragement, and giving me a reason to be here doing this, because this is fun, but like, would I really put in all the effort? Like, you give me structure or something. I don't know what I'm trying to say. I'm glad that I'm streaming this stuff, even though I'm not making tons of progress on it. It's just like, it motivates me, because it's like, okay, I gotta stream tomorrow. What am I gonna work on? Well, I'm gonna work on the touchpad stuff, because otherwise I might not ever do it, right? or I'm gonna build a keyboard, or I'm gonna design something. It's, you know, having this, like, I've got to come up with something to stream about 3 times a week gives me, you know, I need to figure out what to stream about 3 times a week. It helps motivate me to do stuff. So that's cool. So I don't remember if I mentioned it last week or not, but I'm going to start doing streams Monday, Wednesday, and Saturday, 11 a.m. Pacific time. And today was Monday, so my next stream will be Wednesday. And yeah, if I get anything major done between streams, I will try as hard as I can to recap. Like, if I come back next stream and I'm like, look, it's in ZMK, it's already done, I'll try to recap that stuff. Or at the very least be like, okay, I'm making some significant progress here, I need to start streaming just to capture it, right? It may be an off-schedule stream or something, but we'll see. I'll try to keep the, like, breakthroughs on stream and the mundane, still waiting for this clone to happen stuff off stream. So thank you all. Thank you, Brick. I don't remember what the name was. Let's see. Cyan Duck. Thank you, Cyan Duck, for the "'Twas Another Great One." Thank you, Linux Fish, for the good luck, and I'll see y'all on Wednesday. Hopefully I have a Zephyr, like my own Zephyr build going. So excited about that. See ya.